Hello everyone. I am Kulpreet Kaur from BSc Chemistry Honors final year student. Today I am going to prepare an audio recording for visually impaired student on the topic of uses of organic and inorganic reagents in organic analysis. Introduction. Reagents are those compounds which are used in organic analysis for the detection and determination of ions and molecules. A large number of organic as well as inorganic reagents have been used for this purpose. The organic precipitating reagents generally precipitate the inorganic species are strangely soluble salts or hydrous oxides. The organic precipitating agents form serpently soluble products either through coordinate linkage or through ionic linkage between the inorganic species and the organic precipitating reagents. Advantages of using organic reagents. The advantages of using organic reagents are listed below. They are more specific than conventional reagents under certain conditions. Because of this property, they can frequently be used to detect a single type of ion in a complex mixture. They can be more sensitive. Classical semi-micro methods of qualitative analysis will usually not detect much less than 100 gammas of a substance under specific test solution. Organic reagents, on the other hand, are capable of detecting below 10 gamma and in certain cases as little as 10 raised to power minus 3 gamma. They can be adopted in quantitative analysis. The organic precipitates are generally insoluble in water at a given pH and they can separate it, deride and weighted. Those reactions giving colored soluble products frequently show a regular change in color intensity with concentration of the substance under test and so are adaptable to an accurate comparison with colors representing concentration. This is the basic idea in the branch of colorimetry. Common properties of organic reagents. Some of the common properties of organic reagents due to which these are used in organic analysis are given below. Formation of colored precipitate. Organic reagents form direct characteristic color with the ion to be detected for locating endpoint, that is as direct indicator employed in volumetric titration. Formation of precipitate due to difference in solubility. This may be made on the basis of a gravimetric method. Extraction in between solvent at controlled pH. Masking reagents. This increases the selectivity of reagents. Difference in volatility, oxidation or reduction or to other valency state. Uses of organic and inorganic reagents in organic analysis. Wash liquids. The chemical nature of the organic reagent is important in determining the use of above mentioned properties. Advantages of organic reagents over inorganic reagents. It is due to the flowing properties that they are better precipitating reagents than inorganic reagents. Selectivity. In many cases, organic reagents are somewhat specific. For example, cobalt from nickel using alpha nitroso beta naphthol or dimethylglyoxime, aluminium from iron using kupferon, cadmium from copper using quinolidinic acid and thiourea can be precipitated. In some cases, adjustment of the pH will often cause precipitation of one constituent alone. By changing pH and solvent condition, one constituent after another can sometimes be quickly precipitated out. As of drying, organic reagents produce compounds that have little affinity for water and are dried easily at temperature low enough to prevent decomposition. Third is co-precipitation. Lack of ionic character of organic precipitation products greatly reduces co-precipitation in most cases. For example, the co-precipitation of sodium and potassium with magnesium is much less than when the latter is precipitated by 8-hydroxyquinoline than when it is precipitated by phosphate or oxalate. Some expectations in metals do occur. It has been little studied, but in some cases it is as bad as in organic precipitants. Reagents are usually insoluble in water, therefore it is important not to add an excess of reagent. This is difficult because there is no way to tell when sufficient reagent without excess has been added. Any excess that is insoluble would add to the weight of the precipitate. Disadvantages of organic reagents. There are unfortunately disadvantages to using organic reagents. First, volatility. This is the first practical disadvantages of organic reagents because chelatic compounds are non-polar. The forces between individual molecules in the crystal are not very great. Thus, some of the metallic complexes which are precipitated in the analytical chemistry are appreciably volatile above 130 to 150 degrees Celsius and most decompose about this temperature. Therefore, the drying of precipitate should be done below 130 degrees Celsius to avoid decomposition. Impurities in reagents. It is very difficult to prepare an organic reagents of the same degree of purity as say inorganic compounds. Impurities present in organic reagents may enter into the precipitate during the precipitation and cause undesirable reactions. For example, dimethylglyoxime exists in three forms: alpha, beta, and gamma. Of these, only the alpha form is specific for nickel, while preparing dimethylglyoxime alpha. Gamma form is also formed along with alpha form. If the precipitation is carried out with this impure dimethylglyoxime, then nickel will be precipitated with some other metals because alpha form is specific for nickel, whereas gamma form can precipitate other metal also. Keta isomerism in such compound as dithiazone will cause errors in colorimetric work unless conditions are carefully selected. Third is low solubility of the reagents in water. This is the greatest disadvantages which organic precipitants have in comparison with inorganic precipitants. High molecular weight. The very high molecular weight of chelate complexes formed with metal ion reduce proportionally small errors in precipitation and weighing. Fifth, color compound. Chelate compounds are often highly colored, and since they are usually soluble in organic solvents, they lend themselves to colorimetric or photometric methods of analytic solubility in organic solvents. Because of their covalent nature, most metal complexes with organic reagents are soluble in non-polar solvent. Chloroform being usually the best, such solvents are used to extract the complexes for colorimetric determination, or they may be used simply for separating one element from another. Thus, the complex of kupferron with tri-positive ion is very soluble in ether and chloroform, which allow one to remove large amounts of iron from solution containing AI. In these extraction, the pH must be carefully adjusted to give the desired separation. Important organic reagents. Some of the organic reagents which are generally used in the identification of ions are discussed below. First, oxime C9H7ON. This structure of the reagent is given. It is almost a colorless solid soluble in organic solvents and mineral acids. It gives yellow color, which may be due to the formation of cunoid structure. It was introduced by Hallam and Berg in 1927 as analytical reagent. A number of metals give coordination complexes with these reagents. Examples of such metals are magnesium, zinc, copper, cadmium, plumbum, aluminium, iron, boron, gallium, thorium, zirconium, etc. The formation of the complex compound with a bivalent metal ion like Zn2 positive is shown below. The quantity estimation of the complex is carried out by drying and weighing the hydrated or anhydrous complex is ignited to oxide and then weighted. In volumetric methods, the precipitate is dissolved by filtering with hydrochloric acid and then resulting solution is titrated against standard potassium bromide solution. In spectrophotometric method, the estimation of the metal ion is carried out by the measuring the optical density of the complex. The reagent has been found to be suitable for magnesium, aluminium, etc. The reagent is a 2% solution of oxime in 2N-acetic acid. Dimethyl This reagent was discovered by L. Tchefgaff 1905 and was applied by O. Brunk for the determination of nickel in steel. The structure of the reagent is shown in figure. This reagent gives an insoluble red chelate with nickel 2 positive ion in ammoniacal medium. For details see application for the formation of chelated complexes discussed in chapter on the basis concept of coordination chemistry. Solution of palladium salts gives characteristic yellow precipitate in dilute HCl or H2SO4, but nitrate ions interfere. Solution of bismuth salts also gives a yellow precipitate in presence of EDTA at pH 11 to 11.5. For this studies, 1% solution of the dimethyl glyoxime in alcohol is employed. In spectrophotometric method, the insoluble precipitate is extracted into chloroform which yields yellow coloration, and then the optical density is measured. Alpha nitroso beta naphthol, also called 1-nitroso 2-naphthol. The structure of this reagent is shown given figure. It is an orange brown powder having melting point of 109 degrees Celsius, soluble in organic solvents but almost insoluble in water. The reagent is usually employed as a saturated solution in 50 degrees Celsius. 50% is used specially for the direct detection of ferric iron, copper and cobalt with palladium and uranyl salts in slightly acid solution. It gives insoluble colored compounds under suitable condition. Nickel and magnesium, however, are not precipitated by this reagent. Therefore, the reagent in acid solution is used for the separation of nickel from cobalt. The structure of the chelated complex formed by this reagent with copper 3 positive ion is shown at B. The reagent has also been used for the spectrophotometric determination of cobalt and a few other metal ions. It is also used for spot test of cobalt. Kupferon exists largely not in the nitroso hydroxy form A but in the tautometric amine oxide form. The reagent is usually employed as a 6% aqueous solution but is most useful in strongly acidic solution. In strongly acidic solution, it precipitates iron 3, cerium 3, Nb, Ta, W, Ga and Sn2, Cu2 etc. Precipitates should be filtered immediately after their formation because kupferon is not very stable in acidic solution. Furthermore, precipitation should be carried out in cold since the reagent is decomposed into nitrobenzene on heating. The precipitates cannot be weighed after drying but must be etinated to the corresponding oxide and then weighed. The formation of chelated complex with Cu2 positive ion has been shown as follows. Aluminone. It is a aluminium salt of urine tricarboxylic acid. Its structure is shown given figure. It is a brownish red powder freely soluble in water. It forms brilliant colored lakes with certain metals, especially aluminium, with which it gives a bright red lake. Aluminium is a dye and it is very important reagent for spectrophotometric determination of aluminium. By adjusting pH of the test solution below 7.8, it is possible to estimate 0.005 mg of aluminium even in the presence of calcium. The reagent is prepared by dissolving 0.1 gram of the substance in 100 ml of water. Rubianic acid, also called dithioxamide. This reagent is the diamide of dithioxalic acid and is an equilibrium mixture with its tautomeric diamido form. The Ac form combines with nickel, cobalt and copper of give colored water insoluble inner complex salts whose composition is shown given figure. The copper, cobalt and nickel compounds are quantitatively precipitated from strongly ammoniacal solution in strong mineral acid solution. Rubenic acid reacts only with certain element of platinum salt. In addition to above, rubenic acid forms colored compound with silver, mercury, bismuth and iron 3. Rubenic acid is not only important as spot test reagent but also as a gravimetric and spectrophotometric reagents. Rhodamine B. It is tetraethyl rhodamine and it is represented by the structure of given figure 18.7. Solution of antimony salts in strong hydrochloric acid reacts with rhodamine B and the aqueous solution of the reagent changes from red to violet or blue and finely divided precipitate separates immediately or after standing. Trace amounts of antimony may be detected in the presence of large quantities of tin by means of this reagent. Small amount of iron do not interfere. Mercury, gold, palladium are precipitated while molybdates and tungstates in acid solution give color reaction with rhodamine B similar to those given by antimony salt. The freshly prepared benzene solution of the rhodamine B is preferred to the aqueous solution. Benzidine. Its structure is given in the margin 18.8 figure. It is a basic reagent and is employed in slightly acidic solution as dihydrochloride for the precipitation of sulfate as the resulting precipitates may be titrated against standard alkali. The important drawback of the method is the relatively high solubility of the precipitate in water and even more in dilute hydrochloric acid. It also precipitates anions like phosphates and tungstates and give crystalline precipitates with a number of metallic ions such as silver, copper, cadmium, gold, zinc, etc. with cobalt 3 and T3. Benzidine yields a blue coloration in alkaline medium which is an important spot test for metal ions. Recently, benzidine in dilute acetic acid has also been employed as a spot test reagent for the identification of some platinum metals like osmium, iridium and platinum. Cupron or alpha benzoin. Its structure is given for figure 18.9. It is a white crystalline solid. It is strangely soluble in water but fairly soluble in alcohol. It also exists in isomeric beta form. Cupferon is used as a reagent for the quantitative determination of copper, molybdenum and tungsten. Alcoholic solution of cupferon gives a green precipitates with ammoniacal solution of copper salt. Precipitation of other metals in ammoniacal medium is prevented in the presence of tartaric acid. The given precipitate is soluble in dilute mineral acid. Copper can be estimated but volumetrically and gravimetrically by this reagent. The green precipitate is an inner complex whose formation can be shown. Kupferin also precipitates molybdenum and vanadium ions quantitatively, but in strongly acid solution vanadium gives a yellow precipitate while molybdenum gives a white precipitate. Tungsten and palladium also appear to be quantitatively precipitated with the alpha benzoin oxide. Figel have recommended the use of the reagent for the detection of basically in slightly soluble materials such as Al2O3, BaCO3, etc. Magnesium. The structure of this reagent is given figure 18.10. It is also called para-nitrobenzene, azoresorcinol 1 to 0.5% solution in 0.25 in NaOH is generally employed in alkaline solution. It forms a bright blue lake with magnesium ions. The sensitivity of this test is influenced by the presence of ammonium salt, so their presence must be avoided. Azulene S. It is azulene sulfonic acid whose structure has been shown in figure 18.11. It is a dye whose sodium salt is insoluble in water and is employed as an analytical reagent. Aluminium salt gives a red precipitate with the violet solution of a azulene S in ammonia. This complex is an absorption complex of aluminium and azulene sulfonic acid. Absorption system of this type containing metal hydroxide and a distuff are called lakes. Zirconium forms red-violet colored compounds with the reagent under the alkaline source condition. Boric acid also forms brilliant red UV light by adrenaline in H2SO4. The reagent has been employed as a spectrophotometric reagents for the above metal ions as well as a few others. Furthermore, its applicability as absorption indicator in the titration of FeCN6 whole the power 4 negative MoO4 whole the power 2 negative has also been reported. Structure of azulene is figure 18.11. That's all about the organic reagents in inorganic analysis. Thank you so much.